Barc revision series. So we have started from basics of signals and system. Almost we have completed from the beginning of Fourier series in time domain. So we have been completed Fourier series. Then we have completed Fourier transform. In Fourier transform, we have discussed about continuous time Fourier transform. Then we were also completed discrete time Fourier transform. Then we were discussed about Z transform. Then we have completed sampling theorem. Then we have also completed Laplace transform. Then in the last session, we have completed the basics of signals, one of almost 70% of basics of signals has been completed. So let us start from there. We will continue the other things that we left in the last session. Actually, we have seen almost all type of important signals in continuous time domain. Now, let us complete from there. We have to discuss about some of important signals in discrete domain also. So, if you observe some of the standard basic representation of the signals in discrete domain, the first one is as usual impulse signal. The first signal is impulse signal. If you are observing the nature of the impulse signal in discrete domain, I will show you. Okay, I'm sorry. Okay. So the first one is in discrete domain, we are discussing about impulse function. First of all, in discrete domain, representation of the signal is by using n. And we know n is indicate integer values. We will have to consider discrete values 0, 1, 2, 3, and so on. Fractional values are not allowed in time domain. We will be considering only in proper complete values. Now, the representation of the signal is like x of n, y of n, h of n. This is how we are representing the signal in discrete domain. For an example, suppose the first signal here I am representing is impulse function. As I told you, we are going to start from the impulse signal. First, if you observe the representation of the impulse signal, we have seen in continuous domain, it is represented as del of t. Whereas in discrete domain, the same signal will be represented as del of n. First thing. And what we saw in continuous domain, this signal will be represented as, just to recollect once, the value of del of t will be approaching to infinity. We have seen at t equal to 0, and it will be 0 in all other places. Otherwise, it will be 0. Elsewhere, it will be 0 everywhere. This is what we have discussed. Here, I have given some of the properties. The another most important property of your impulse function in time domain is throughout the integral from minus infinity to plus infinity, del of t into dt value will be approaching to 1. That is the another most important property. Of course, you will have to keep these things in your mind because they are very, very important. And another thing, in the same way, if we are figuring out the value of impulse function in the discrete domain, I will tell you the value of del of n can be written as, in discrete domain, this can be represented as a summation del of n equal to, this value will be 1 when the value of n equal to 0, and this value will be approaching 0 in all other places. That is the representation of your discrete domain signal, del of n, impulse signal. And in discrete domain, suppose if I am writing it, if I am representing it in a sequence manner, how should I represent it, sir? This del of n will be represented like this. At n equal to 0, the value of this function will be approaching to 1, and this value will be 0 in all other places, etc. Both left hand side and the right hand side, everywhere this value will be approaching to 0 only. This is the generalized representation of the impulse function del of t. Now let's continue from there. So this is all about the first simple representation of the impulse function. Now suppose if the value of del of n has been represented like this, let us consider I am having del of n minus p. Then how will you represent this function? Del of n, if you are taking del of n usually stands at n equal to 0 because its sampled position is at n equal to 0. We are considering this value will be approaching to 1. Similarly, if you are having del of n minus p, then this function will be assumed to be, this value will be approaching to 1 at n equal to p, when the value of n will be approaching to p. So if del of n minus, for an example, if del of n minus 3 is given to you, if del of n minus 3 will be given, how will you represent it, sir? The value of this impulse function will be approaching to 1 only at n equal to 3, and it will be 0 in all other places. That is the generalized representation of the impulse function in discrete time domain. Just recollect once, okay? So now let us see some of the most important properties of the impulse function. Of course, they are very important too. I will tell you now. For an example, let us assume I have a signal x of n, some random signal. I have some random signal x of n. This random signal has been multiplied by the value of del of n. Then, how will you write down the resultant expression for this function? I hope you all remember same thing. In time domain, what I told you, whenever you are observing a function x of t, any general function, it has been multiplied by del of t. In multiplication, normal multiplication, this answer, this function, same function can be rewritten as x of 0 into del of t. Why we are writing such like this? Because the position of del of t, the value of del of t will be approaching to 1 only at t equal to 0. This will be lying only at t equal to 0. In rest of all other places, the value of impulse function value will be 0. If it is 0 in all other places, if I am multiplying with some other function, this other function will exist only at the location of the impulse function existence. See. So like that, if you are multiplying x of n with the del of n, then the resultant answer will be approaching to be x of, since del of n will lies only at the origin, so you will have to write down your answer x of 0 into del of n like this. Sir, suppose if it is given, I have a function x of n, there is no problem. But del of n has been shifted to some position. Let us take the random position is p. Then the resultant answer will become, how will you rewrite this function, sir? This function can be rewritten as, some of you are writing like this. Listen. Can I write like this? Del of, this function, can I write like this? X of n minus p into del of n. Del of n minus p. Is it correct, sir? If you are writing like this, then I will say your answer is absolutely wrong. Because observe the basic property. What I was doing here, the value of n will be standing at 0. So we are just substituting the value at n equal to 0, this function will exist. Not n minus p. If del of n minus p will be given, it means the function del of n will stands at the point of n equal to p. Now what is the point, sir? P will be the point. So in place of x of n should be replaced by p, not n minus p. So the correct way of writing this expression is, you should not write n minus p, rather you should write x of p only. So the correct way of writing this one is x of p into del of n minus p will be the correct answer. Hope you will not forget. Okay, so don't do this mistake. Please be aware of this. So let's continue. Suppose if I am having in continuous domain, what is the another most important property of impulse function? Let me define. In continuous time domain, we have seen throughout the integral from minus infinity to plus infinity, if I have a function del of t with respect to time period dt, then you can write this value is 1. Now, in continuous time domain, we have also seen, just recollect once, if this same function will be multiplied by x of t into del of t with respect to dt, then you will have to write down your resultant answer is x of t, where the value of t will be approaching to 0. Correct, no, sir? This is what we were discussed in time domain. One more thing, actually I forgot to return there. Suppose if it is given minus infinity to plus infinity, x of t into d power n times of del of t upon dt with respect to dt. What will be the resultant answer for this, sir? The resultant answer is minus 1 whole power n into d power n upon dt power n into x of t. At last, after completing this differentiation, you can replace t by 0. Don't forget, this is one of the most important property. For an example, I will tell you, this is continuous time domain only. For an example, let us assume, I will consider some example for this. It is given that integral of minus infinity to plus infinity e power minus 3 times of t into d square upon dt square into del of t into x of t. You will be requested to find out the answer for this question. If you remember the property, it is easy for you to give the answer within fraction of seconds. See that in place of x of t, what we are having? In place of x of t, we will be having e power minus 3t. Correct, na, sir? That's it. And here, just write down the formula. The resultant answer will be minus 1 whole power. In place of n, we will have the order of the differentiation. What we have? N equal to 2 here. So this can be written as d square by dt square into e power minus 3t. At last, after completing the differentiation, replace t by 0. What will you obtain, sir? The answer is going to be minus 1 whole square will become plus 1. So that will be plus 1 dot. We will have to differentiate this e power minus 3t 2 times. If you are differentiating e power 3t 2 times, what will happen? First time it will give you minus 3. Second time it will give you one more minus 3. Then at last the resultant answer will be minus 3 into minus 3 will become 9 into e power minus 3t. After completing the differentiation, t will be replaced by 0. If you are doing that, e power 0 value will become 1. So 1 into 9, your resultant answer will be approaching to 9. Understand, sir? This is one of the most important property of impulse function. Anyway, we have discussed all these things in continuous time domain. Whereas now we are in discrete time domain. So in discrete time domain, if we are considering same impulse function, I will tell you. The impulse function is, we are representing it in discrete domain is del of n. Now, in discrete domain, it can be rewritten as same interval, but instead of using integration, we will have to use summation here, n equal to minus infinity to plus infinity, and of course, we will be having the value of x of n. Let us assume I am having x of n with the del of n only, simply. If it is given like this, then what will be the resultant answer, sir? Same property. In continuous domain, whatever the things that you did, you can take. So the resultant answer will become x of n, where the value of n will be approaching to 0. And now the general property is, if you are writing the general property, n equal to minus infinity to plus infinity. If I am summing up all the value of del of n, this will be approaching to 1. Same thing. If it is multiplied by something x of n, then x of n will come to that position. Now, suppose if it is given that n equal to minus infinity to plus infinity, I have the function x of n, and of course we are also having one more function del of n minus p. Then what will be the resultant answer, sir? This resultant answer will become simply x of n only, but where the value of n will be approaching to p. So that is what you have to understand whenever this function will be given to you in the examination. Now let us assume summation n equal to minus infinity to plus infinity. I have a function 2 power, let us take 2 power n. 2 power n into, it is given that del of n minus 2. This is what given. Now what you will have to do is, what will be your resultant answer? The resultant answer will be, this x of n will be coming out. So this will be simply come out 2 power n, whereas the value of n will be approaching to 2. N minus 2 means n equal to 2, so your answer will be 4. Finish. So it is very simple. If you remember the properties, you will be able to solve this type of questions in an easiest manner. All you have to do is remembering these values in a proper way. Now there are few more properties for del of t, del of n I will give. They are very important in examination point of view. So the first most property is relation between impulse and step function. in discrete domain, relation between u of n and del of n. Relation between u of n and del of n. This is one of the most important property of del of n function, of course often being repeated in the examination also. Let's see what I have to say. Conclude here is, I am having u of n, yes, and we are also having the value of del of n. What is the relation between these two people? If we are having a function del of n, then that function can be rewritten as u of n minus u of n minus 1. That is the basic relation. You can draw it, sir. See, it is very simple. If you are good in drawing this waveform, that will simply tell you how will you draw the waveform for u of n. U of n can be drawn as, from n equal to 0 onwards, this value will be approaching to 1. U of, at n equal to 0, it is having 1. At n equal to 1, it is having 1. At n equal to 2, it is having 1. At n equal to 3, it is having 1. So this is 1, 2, 3, and so on. Now if you are considering u of n minus 1, I can write this function as, if you are considering u of n minus 1 means this signal will start its operation from n equal to 1 onwards, not from n equal to 0. So this signal from n equal to 1 onwards, this value will be approaching to 1, 1, 1, and so on. Now if you are subtracting u of n with the u of n minus 1, what will you obtain, sir? At the origin we have 1, here at the origin we have 0. So 1 minus 0 will give you 1 only. The resultant answer, if you are subtracting these two waveform, the resultant answer is going to be, at the origin it will be giving its value. At the origin we have 1. At the origin we have 1. What about at n equal to 1, sir? At n equal to 1, here also 1, here also 1. 1 minus 1, 0. At n equal to 2, 1 minus 1, 0. At n equal to 3, 1 minus 1, 0. So everywhere it is 0 except at n equal to 0. If your function will lies only at n equal to 0, this is actually written as u of n minus u of n minus 1. Absolutely we are correct. But this function can also be what we are calling it as, if your function is lies only at n equal to 0 and that value is 1, that is nothing but del of n, sir. We saw now the value of del of n will be approaching to 1 at n equal to 0. And it is 0 in all other places. So u of n minus u of n minus 1 equal to del of n. That is another most important property of an impulse function. And suppose it is given that, let us take summation of, what we are doing is, a signal will be running from 0 to infinity. Impulse function is running from 0 to infinity, and we are adding all these values. From n equal to 0 to infinity, if you are adding all the values, it means what? At n equal to 0, we have a function, what I can say, at n equal to 0, we have 1, and then at n equal to 1, this function will become 1, at n equal to 2, it is 1, at n equal to 3, it is 1. So if you are representing a function del of n from 0 to infinity, then what will be the value of this resultant answer? This will be approaching to step function u of n. This is called impulse train. Impulse train will be equal to, it is running from 0 to infinity. If an impulse function will be running from 0 to infinity, then that will be equal to the value of, its equivalent value will be u of n. That is the another most important property, and of course we are calling it as impulse train in discrete domain. Impulse train will always be equal to step function. So all you have to do is just understanding it, how to represent it. Now suppose if you have ramp function, so step you have understand directly from impulse. I will tell you if you want. See, it is very simple. If it is given that u of n, it means a signal step function will be represented as, it is represented like this with respect to n. At n equal to 0, this value will be approaching to 1. At n equal to 1, it is approaching to 1. At n equal to 2, it is approaching to 1. At n equal to 3, it is approaching to 1, and so on. This is the representation of a step function. Okay. Similarly, how will you represent the ramp function in discrete domain? The representation of a ramp function x of n equal to n times of u of n. That is the representation of a ramp function. It means if you are developing the ramp function, I will show you. If we are developing ramp function, how it will grow, sir? At n equal to 0, this value will be 0. At n equal to 0, it is 0. At n equal to 1, it is 1. At n equal to 2, it is 2. At n equal to 3, it is 3. At n equal to 4, it is 4. At n equal to 5, it will be 5. At n equal to 6, it will be 6. At n equal to 7, sir, it will be 7. This is how your ramp function will be continuously growing. That is the representation of the ramp function. Okay, sir. So you should know how to draw the ramp function in continuous time domain. Similarly, there is another most important function, that is rectangular and triangular function representation in discrete domain. So that is just, you can have a small look into that. Let's look into that. So the next one is representation of the rectangular function in discrete domain. If we are having a rectangular function, how should I represent it in discrete domain, sir? So it is very simple. First of all, the value of the rectangular function will be represented like this: x of n equal to, as usual, as I already mentioned it to you all, this will be a times of rectangular of, there I was representing t by tau. In continuous domain, it was written as t by tau. Whereas in discrete domain, we are representing it by n by n, n by capital N. So here you can consider the better, we can take general twice of n. This is how we are representing a rectangular function. So this value will be, so its magnitude will be approaching to a, and 2n it's represent the width of the signal. So based on the n value that they are giving, you can draw the waveform. Similarly, if you are observing the triangular function, I will be writing directly. A triangular function can be written in the same way: a times of triangular of, a times of triangular of, this will become simply n by n only, small n by capital N. This is the representation of the triangular function. That's it, sir. So all you have to remember is how to draw these waveforms in continuous time domain and discrete time domain. So don't forget what are the signals and signals that I had given till now, because these all are very important. Questions will be directly asked from the basic properties, especially impulse property. The first one is whatever we discussed, especially they are all called impulse properties of the signal. So you have to remember what are the things that we have discussed there. Okay. Apart from that, you must understand some of the standard signal. We will be starting from there. The first one is, if you are talking about the standard signals, the first one I will be directly going, not with any other signals. The first one you have to recollect or remember is periodic signal. The next most important one is periodic signal. So basics are over. The next most important signal is periodic signal. So what is the meaning of periodic signal, or how will you represent a periodic signal? Is there any condition, or is there any way to represent the periodic signal? Yes. How will you represent? So the condition is, if any signal is repeating, if it is given like this: x of t equal to x of t plus or minus t, plus or minus anyone. What I am trying to mean here, the thing is, suppose let us assume in our x and y axis, if you are observing that there is a signal. Let us assume I am having a rectangular function or triangular, anything you can take. See, for an example, I have a triangular function. The triangular function nature will be, it is constantly repeating itself. It is continuously traveling like this. So the nature of the signal will be running from minus infinity to plus infinity. It will be constantly running. So let us assume, observe this signal. What its nature is, let us say this is 0 and this is going to be t and this will be 2t and so on. And here this will be minus t and this will be minus 2t and so on. So what you can understand by observing this signal, sir? By observing this signal, only one thing you can easily realize, that The nature of the signal, for every t interval, the nature of the signal will be again and again repeating. For every interval of t, the nature of the signal will be again and again repeating. That is what we can conclude from here. Yes. So what I would like to say from here is, the finalized conclusion from here is, if I am treating the first signal as your x of t, then this signal, the second sample is written as, the total period will be t, but this signal will be starting at 2t. So this can be this can be written as x of t minus t. Sorry, this can be written as x of t minus t. X of t minus t means there is one more signal that will be starting at t equal to t. After that, it will be running over the period of same sample, same period. It will be running for the same period, and it will be repeating the nature of x of t. So x of t and x of t minus t both are same. And again, what you can say, this signal, there is one more signal that will be starting at x of 2t, that is t minus 2t. All these people are equal to each other. Now, if you are observing on the left hand side, see that this is x of t, and this is going to be x of minus t, I can say. And here this one can be written as x of minus t only, which starts at what? Minus t. So this can be written as x of minus t minus t. On the left hand side, it is repeating its nature. So what is the conclusion here, sir? If any signal will be throughout the period, between the period of minus infinity to plus infinity, with this sampling interval, with a particular time interval, if it is again and again repeating its nature, from minus infinity to plus infinity, it should repeat. The period is very important. Periodic signal is the one which is always repeating its nature again and again. Same nature will be again and again repeated from minus infinity to plus infinity. Then that signal will be considered as a periodic signal. Hope you will not forget. Suppose if it is given that, you can consider some other signal. For example, I am considering one more signal for your understanding. What I am doing here is, what I am going to do here is, let us take what people given is one rectangular function will be given. Let us assume we are considering a rectangular function. So they have drawn the waveform like this. Assume like this. Okay. This is how the waveform is given. And on the left hand side, what they have given is nothing. They left. On the left hand side, there is nothing. Here it is empty. On the right hand side, this signal is running from 0 to t. Then this 2t, 3t, 4t, 5t, and it is running up to infinity, from 0 to infinity. Given that rectangular function, maximum value is plus 4, minimum value is minus 4. With this sample interval, it is running from it is running from 0 to infinity. It is given that it is running from 0 to infinity. If I am asking you, tell me whether this given signal is periodic or not. The question is whether the signal is periodic or not. What you should not say here is periodic signal 1. Periodic signal is the one which is repeating itself again and again from minus infinity to plus infinity. Whereas if you are observing the given signal from minus infinity to 0, the magnitude of the given signal will be 0. Whereas it is running from 0 to infinity without changing its property. So this signal cannot be treated as a periodic signal. It may repeat its nature from 0 to infinity, but it is not repeating its nature from minus infinity to plus infinity. Because of that, this signal cannot be considered as a periodic signal. That you must remember. That is all about a periodic signal. Now, from periodic signal, the most important thing is, how should I calculate the fundamental time period of the signal? The fundamental time period. For example, it is given that a function is defined as 10 into cosine of 5 pi t. Find out the fundamental time period of the given signal. The formula to find out the fundamental time period is t is equal to 2 pi by omega, whereas omega is the coefficient of time period t, cos of omega t, that is the representation. So here, what is the value of omega, sir? Omega value is 5t. So the fundamental time period of the signal is 2 pi by 5 pi. 5 pi will get cancelled. So your answer is going to be 2 by 5. That is the fundamental period of the given signal. Or you can say this will be 0.4 seconds. That's it. That is how we are defining the fundamental time period. There are so many examples you can take. Cosine, cos. They will give sinusoidal signal or cosine signal, or they will give exponential signal also. But make sure exponential signal will be given. They will be represented in terms of j. Without j, you cannot consider the fundamental time period, sir. If a signal will be given without j, if it is given as e power minus 2t, and if they are asking you to find out the fundamental time period, you will have to define that the given signal is aperiodic signal. Observe whether operator j will be present or not. Then only it will come in terms of cosine and sine. So what I can say is, suppose it is given that e power j times of 5, let's take 3 pi t. What is the fundamental time period? The fundamental time period of the given signal will be 2 pi by omega. As usual, the value of omega is the coefficient of t. The coefficient of t is 3 pi. If we are cancelling it, then your answer will become 2 by 3 seconds. That is the fundamental time period of the given signal. Sir, if you are having more than one signal, then how should I calculate the fundamental time period? The next question is, if you are having more than one signal, if it is given that, for example, let us say, I am having a signal x of t. It is defined as 10 into cosine of 3 pi t plus 15 into sine of 5 pi t. Now the question is, find the fundamental time period of the signal. In order to know the fundamental time period of the signal, what you have to do is, first you should figure out whether the given signal is periodic or aperiodic signal. Periodic signal or aperiodic signal. Let us see. For that, find out the fundamental time period of the first signal. Let me consider the fundamental time period of the first one is t1 and the fundamental time period of the second one. Time period of the second one is t2. So t1 can be calculated as 2 pi by omega 1. Omega 1, its correspondent frequency. In the question it is given that 3 pi. So substitute here. What we are getting here? 2 by 3. Now calculate the value of t2. T2 is going to be 2 pi by omega 2, whereas the value of omega 2 is 5 pi. So from this, if I am cancelling pi, you will be getting 2 by 5. After this is step number 1. To calculate this fundamental period of any signal, when it is having more than one signal, then this is the procedure. Find the value of T1 and T2. Then in the second step, take the ratio between T1 and T2. If I am taking the ratio between T1 and T2, the value of T1 is going to be 2 by 3 and the value of T2 is going to be 2 by 5. From this, 2 will get cancelled. The resultant answer will become 5 by 3. Now the resultant number is a rational number. The resultant, after taking the ratio, the resultant value is a rational number. Then you can say the given signal is the periodic signal. The given signal is a periodic signal. The given signal is a periodic signal. Otherwise, it is not. That you should define properly. Okay. So this is how we are defining it. From this, sir, how should I calculate the fundamental time period? That is very easy. The next step. Oh, I'm sorry. The next step is T1 by T2 equal to what it is given, sir? 5 upon 3. Now just take the cross product of this one. 3 times of T1 equal to 5 times of T2. We can write like this. After writing this, take either 3 times of T1 or 5 times of T2 to calculate the fundamental time period. That's it. This is the formula. 3 times of, what is the value of T1, sir? The value of T1, what we found already is, go back. T1 value is 2 by 3. T1 value is 2 by 3. Just a substitute here. 3 will get cancelled. So the fundamental time period value will become 2 seconds. You can also calculate this with the help of the second one. The second one is 5 times of T2. With the help of this, we can easily calculate it. That's it, sir. This is how we are calculating fundamental time period of any signal it will be given. See, here what you have to remember here is sometimes it is very important. The another way what some of you are doing now. See, sometimes what will happen is while taking the ratio between T1 by T2, the answer will not be a proper rational number. It will be an irrational number. Like you may be getting 1 by root 2, or there will be a possibility of getting 3 by root 6. If you are unable to take directly, if you are unable to take the proper value inside this from the root, then you cannot consider as a periodic signal. This is aperiodic. This is not proper rational number. So while taking ratio between the time periods of the first signal and the second one, first signal and the third one, if three signals are given, then how will you take the ratio? First you take the ratio between T1 and T2, then take the ratio between T1 and T3, then take the ratio between T1 and T4. Now, while taking the ratio between this signal, if any one of the ratio is an irrational number, you are unable to find out the proper fraction, then you can say that the given signal is a aperiodic signal. Directly you can define that. Hope you understand, sir. So this is all about periodic signal. All you have to do is just to remember it in a proper way. Okay, that's it, sir. From this periodic signal, if they are asking periodic frequency now, after calculating fundamental time period, since we know frequency will be reciprocal of time period. If they are defining it in omega, then directly define it in terms of 2 pi f. There is one more shortcut also. What you can do is, suppose if a signal is given sin 2t plus cos 3t, if it is given, and you observe that both the signals are periodic signal. Okay, sin 2 pi t you can take. Cos 3 pi t also you can take. In terms of pi, I will define. If it is given like this, and you observe that this signal is periodic signal, and what they want is fundamental frequency directly they are asking in radian per second. So the shortcut is directly find the HCF for the given one, 2 pi comma 3 pi. Pi is the common number we will be taking out. That is not a number. We will just take it out that value. And inside that you will be having HCF. The common factor is going to be 2 comma 3. We know. So see, between this, what is the highest common factor? We have only 1. So the value is going to be pi radian per second. This is the fundamental value. But you must know how to calculate the HCF. Without knowing that, you may not be able to proceed further. So periodic signal process is very important signal, very important process, continuously asked in the examination. Hope you all know this. So this is in continuous domain. Same way, you can also calculate the fundamental time period in discrete domain. Same formula. If they are asking fundamental time period in discrete domain, use the same formula, 2 pi by omega. But along with that, use some integer. So what you are trying to say? For an example, it is given. If you are considering any signal, it is given that, let us take cosine of 3 pi n is the signal given in discrete domain. It is given in discrete domain. And you are requested to calculate the fundamental time period of the given signal. How will you calculate, sir? In discrete domain, only proper values are allowed. Means a complete value is 0, 1, 2, 3. Only these values are allowed. Fractional values are not allowed. So while calculating fundamental frequency in discrete domain, for this given signal, if you are writing fundamental time period n is equal to 2 pi by the value of omega is the coefficient of n. It is given that 3 pi into m. So what I have to do is pi will get cancelled, but here I am having 2 by 3 times of m. What should I do? Can I take this 3 here? Can I consider this 2 by 3 in discrete domain? No, sir, you should not consider, because in discrete domain, only what proper integer values are allowed. 2 by 3 is 0.666, sir, equivalent value. That is fractional value. That value is not allowed. What you have to do? What you have to do? Then choose the proper value of m. Whatever the value that you are having here, just to cancel that, you can choose the value. So the minimum value what I have to choose for m is 3, such that the m3 will get cancelled and the fundamental time period will become proper integer value. So in order to obtain the proper integer fundamental time period of any given signal in discrete domain, we will have one more integer factor here, that is called m. For that m, you cannot choose any value. You will have to choose the minimum value, which will be cancelling the effect of the denominator. Minimum value. If denominator is 3, okay, I will choose minimum is 3. Such that 3 will get cancelled. The fundamental time period of the signal will become 2 seconds. Understand, sir? This is how you have to calculate the fundamental time period of any signal when you are observing, when you are doing these things in discrete domain. Okay. The another most important signal is even and odd signal. Let us enter into the another most important signal, that is even and odd signal. Even signal and odd signal. Sir, what is the meaning of even signal and what is the meaning of an odd signal? Even signal is the one which is having, we know it. Even signal is the one for which first and second quadrant are symmetrical to each other. For example, I am having a square waveform. Assume I am having a square waveform. If you are observing in the given square waveform, for the given square waveform, if you are observing left and right hand side, this I can consider as x of t, this portion, because time period is positive here plus t, and this is x of domain, this is x of t. Whereas on the left hand side, here the value of t is minus t. So this period, this signal can be represented as x. On y axis it is x, but in x axis this is minus t. If you observe x of t and x of minus t they both are same. The property of x of t and the property of x of minus t both are same only. From this what you can conclude? If any signal is symmetric with respect to y-axis, if any signal is symmetric with respect to y-axis, both left and right hand side of the y-axis are symmetric of each other, then you can define that signal is an even signal. That's it. One more example what you can take is cosine waveform. We can also consider, if you observe the cosine waveform exactly from origin till pi by 2, you can observe here it is up to minus pi by 2. See that left hand side and the right hand side are reflecting the same nature again and again. So then that is called what? Even signal. So cosine signal, square wave signals, any signal which is symmetric about or with respect to y-axis, then that signal is called even signal. If it is anti-symmetric with respect to y-axis, then that signal is called odd signal. Anti-symmetric means, I will show you. Anti-symmetric means it is given that, for example, let us consider x and y-axis. And when the moment we are trying to draw the waveform pattern, suppose it is given like this, it is running up to here. If your signal is given like this, then how will you define this? It is going to be this signal. This is minus x of minus t, because see, time axis is negative and the y axis also negative, minus x. So minus x of minus t. Minus x of minus t value under this is x of plus t plus x of plus t. Both are having the same properties. If x of minus t, minus x of minus t and x of plus t both are having same property, then that signal will be considered as an odd signal. So if any signal is anti-symmetric, if any signal is anti-symmetric with respect to y-axis, then that signal will be considered as an odd signal. With respect to y-axis, it should be anti-symmetric. Then you can define that signal as an odd signal. So what is as a for odd signal, x of t and minus x of minus t both are equal to each other. That's it. So this is all about odd signal. Just remember, in discrete domain also you can define this in the same way. Hope you all are studied these things already and just recollecting once. Now, if tell me, if any random signal will be given, how will you find out the even part and the odd part? A random signal will be given. X of t equal to, it is given that x of t equal to cos t, and it is, you will be requested to find out the even part of the above signal. How will you find out the even part of the above signal? The formula to find out the even part of any signal, x even part of t, can be defined as, the formula is x of t plus x of minus t by 2. Now x of t is already given. Find out the value of x of minus t. X of minus t means cos of t will be replaced by minus t. What we know? Cos of minus t equal to cos t only. Yes. So what you can do is, now you know the value of x of t, x of minus t. Find the value of x of even part of t. The even part of t will be x of t plus x of minus t divided by 2. So what we are obtaining, sir? 2 times of cos t divided by 2. So we can say complete above signal will be even part only. The above complete signal will be the even part only. How will you find out the odd part of the signal? Odd part formula is, just recollect. The formula to find out the odd part is x of t minus x of minus t by 2. Now what is the x of t value, sir? X of t already we know, that is cos t. Yes. Minus of x of minus t also we know, that is also cos t divided by 2. So this will be 0. What's happening here, sir? For the given function there is no odd part. We know it is cos signal, sir. It is cosine. Cosine is an even signal. For the even signal, how can you find odd property? Odd will be 0. Okay. So this is how you have to find out the even and odd part. So this is the formula to find out. This is odd property. This is the formula to find out the odd property of the signal. This is the formula to find out the even property of the signal. Will it change for discrete domain? No. Even in discrete domain also same formula. Just replace t by n. That will give you the value of odd property of any signal. Hope you understand. Yeah, very very important. The another most important area that we are entering in now, the repeatedly asked question is calculation of energy and power signal. Calculation of energy and power. Keep that in. How to calculate the energy and power of a signal. Calculation of energy and power. Repeatedly asked the question. So from this area, we know questions will be repeatedly framed. Now let us see the formula to calculate the energy and the power of a signal is. Let us see how to calculate the energy and the power of a signal. So when it is given in general in continuous time domain, how to calculate the energy, sir? The energy formula will be, the formula to calculate the energy of any random signal will be integral of minus infinity to plus infinity mod of x of t whole square into dt. This is the formula to obtain the energy of any given signal. How should I calculate the power of the signal? If you are trying to approach, if you are trying to calculate the power of the signal, then the formula to obtain, you see, while calculating power, there are two things. Sometimes your signal will be approaching to, wait, periodic signal will be given sometimes. Sometimes aperiodic signal also will be given. If it is given that, if the given signal is periodic signal, then the power value will be simply the fundamental time period of the periodic signal, and you can run from 0 to t into mod of x of t whole square into dt. Suppose it is given that the signal is running from minus infinity to plus infinity. It is given that the signal is, it is aperiodic signal. Okay, let us assume this is aperiodic signal. For the aperiodic signal, the power formula P is equal to same formula, nothing will change, but aperiodic signal and t will be approaching. It is running from minus infinity to plus infinity, but it is not the periodic signal. In that case, the power formula will be t will be approaching to infinity, and you can run from minus t by 2 to plus t by 2, where t will be approaching to infinity, sir. Where t will be approaching to infinity. This is the formula. This is how we are defining the power formula for both periodic signal and aperiodic signal. So of course you will have to remember it because it is most important properties. So now you know how to calculate the energy of the signal, and you also know how to calculate the power of a signal. Now there is certain property for energy signals and power signal. If the given signal is, it is given that the given signal is energy signal, then what will be the range of energy? You found that the signal is energy signal. Range of energy for energy signal is, what will be the range of energy for the energy signal? If your signal is the energy signal, if your given signal is the energy signal, then the value of the energy must be less than infinity, and of course it will be greater than 0. It should have finite value. The conclusion is it should have finite value. Energy signal, in case of energy signal, the value of energy will be finite. The value of the energy must be finite. It should not be neither infinity nor 0, but it should be finite. Energy value must be finite. Very important. Okay. At the same time, if you are finding the average power of the energy signal, properties. Energy signal must have finite amount of energy. At the same time, if you are calculating power of the energy signal, of course it will be approaching to infinity. Sorry, it will be approaching to 0. Power of the energy signal will be approaching to be 0. Power of energy signal. So energy of the energy signal must be finite and power of the energy signal must be 0. This is the one of the most important property of an energy signal. Similarly, when the moment I am talking about a power signal, let us discuss about a power signal. It is given that the property, if your signal is a power signal, then how should I define the energy and the power of a power signal? I will tell you. The first one, when the moment you are observing the range of the power, if the given signal is a power signal, then the value of the power must be not equal to infinity. At the same time, must be not equal to 0. Rather, its value must be finite. Its value must be finite value. Infinite values are not allowed for the power signal. Infinite values are not allowed for the power signal. So I am repeating again, whenever we are discussing about power signal, the value of the power must be finite and it should not be approaching neither infinity nor 0. Rather it should be finite value. For energy signal, energy will be finite. For power signal, power will be finite. For energy signal, power will be 0. For energy signal, power will be 0. Whereas, what will be the energy of a power signal? If you are observing the energy of a power signal, energy will be infinity. So what we understand here, just remember one thing first. For energy signal, energy will be finite. In case of power signal, power will be finite. If your signal is very power, it's like you can remember like this. If a powerful signal will be given to you, then its energy will be infinity. You cannot control it. If a powerful signal will be given to you, its energy cannot be controlled. It will be infinity. Remember like this. If an energy signal will be given to you, that energy will be finite and will be dries, which in some time it will be decreases to 0. Energy will be slowly decreasing. See, as I am continuously taking the class, if I am continuously taking for till 9 or 10 a.m., what will happen? Slowly my energy will be go, I will become so dry, I will be so tired. So I need some energy. I have to feed it back. So the conclusion is, in case of energy signal, energy will be continuously decreasing to 0. That's why when we are talking about energy signal, the energy value will be finite, its power value will be 0. For a power signal, power must be finite, whereas the value of the energy must be infinity because it's a powerful signal. Remember like that. All you have to do is remembering these keywords. Okay. And the next thing is all type of the one of the most important property. All type of aperiodic, non-periodic signals can be considered as an energy signal. All type of aperiodic signals are considered as an energy signal. General property. One more question. All type of aperiodic signals are considered as energy signal. It means energy of the aperiodic signal will be always finite. Energy of the aperiodic signal will always be finite, and the power of the aperiodic signal will always be approaching to 0 watts. Understand, sir? So you have to remember these two properties, most important properties. The periodic signal will be given. All type of periodic signal, whenever we are observing, all type of periodic signal, you can define. If your signal will be a periodic signal, then that can be treated as a power signal. All periodic signals are periodic signals can be treated as power signal. All periodic signals can be power signal. Can be a power signal. All periodic signals can be a power signal. But it is not vice versa. Means all power signal no need to be a periodic signal. All power signal no need to be a periodic signal. That is another most important property. All power signal no need to be a periodic signal. All power signal no need to be a periodic signal. No need to be a periodic signal. All power signal no need to be a periodic signal. That's it. All power signal no need to be a periodic signal. Understand, sir? What is the difference here? All periodic signal can be treated as a power signal, but it is not vice versa. All power signal cannot be treated as a periodic signal. Understand, sir? Hope you understand. So these two properties are very, very important properties whenever we are discussing about energy and power signal. You can also observe that from energy and power signal there are so many questions in the examination. So try to practice as many questions as been possible from your side. Try to practice. Similarly, we can also define the energy and power formula for discrete domain signal. What is the formula, sir? Let me define. For a discrete domain signal, the formula to obtain the energy. This is discrete signal. If it is given discrete, then the formula to obtain the energy of the signal will be summation. Summation. You can run from as usual minus infinity to plus infinity mod of x of n whole square. This is the formula to calculate the energy of any signal in discrete domain. Whereas, how should I calculate the power, sir? Then the formula to calculate the power in discrete domain is, so anyway you can consider the general formula for any type of signal. Generally, limit n will be approaching to infinity under 1 upon 2n plus 1 into 1 upon, here the formula will be twice of n plus 1 summation n equal to minus 1 to plus n minus n to plus n mod of x of n whole square. Another most important property. But this is the property of a power signal, sir, and the above one is property of energy signal. Whatever the conclusions that I have already given, you can take all the conclusions here also in discrete domain. Like what I told, all aperiodic signals are called energy signal. All periodic signals are called power signal. But all power signals cannot be considered as periodic signal. Then what I told, energy signal, energy will be finite. For power signal, power will be finite. For energy signal, power will be what? Approaching to 0. For power signal, energy will be approaching to infinity. You must remember whatever the property that I have given for periodic and aperiodic signal. Don't forget. So you should practice as many questions as been possible from your side. And the next thing is the another most important one is properties of a causal signal. That is one of the most important and of course repeatedly asked in the examination. Causal, anti-causal and non-causal signal. First, which signal can be considered as a causal signal, sir? Causal signal is the one which is having the value of x of t must be not equal to 0 for t greater than 0. That is called a causal signal. So I can generally define the value of x of t can be any value. I can consider some random value. Okay. What I will do now, I will define the above itself directly. Unnecessarily confusion. See, this value will be not equal to 0 only for t greater than 0. For t less than 0, it will be 0. It will be 0 for t less than 0. 0 for t less than 0. That's it. That is the property of a causal signal. Now, then what is the, which signal is called anti-causal signal? Anti-causal is the one which is having the properties only for t less than 0. Now, if you are considering anti-causal signals, if the value of x of t is not equal to 0 only for t less than 0, or it is 0 elsewhere, then this signal is called anti-causal signal. This is what we are considering it as anti-causal signal. Understand, sir? Then which one is called a non-causal signal? Non-causal is the one which is having the value of x of t is not equal to 0 everywhere. The value of x of t is not equal to 0 for the period of minus infinity to plus infinity. It means for t greater than 0 and for t less than 0, in both periods, this signal will be existing. Then that signal is called non-causal signal. For t less than 0 also it is existing, and for t greater than 0 also it is existing. Then that signal is called non-causal signal. One of the most important, because based on the same property, this non-causal signal we will be applying in Z transform, Laplace transform from the ROC. We have seen na sir, region of convergence. When I was discussing about region of convergence of Laplace transformation and Z transformation, I told causal signal means it is the right sided sequence. Here it is not equal to 0 for t greater than 0, right sided signal. Anti-causal means that is left sided signal. For t less than 0, this will be not equal to 0. Non-causal is the one which is having for on both sides. For t greater than 0, t less than 0, this value will be not equal to 0. So this is all about causal signals. So we have completed almost all important types of signals. It is a revision class. I have done my best. It is not possible for us to explain everything in detail, but we have seen all sufficient things, whatever that you are that is useful for your examination. I have covered almost all things, but still we have one more topic left, that is properties of systems, classification of system. That is the final topic that we are going to discuss on signals and system. So these things we will cover on Monday. Saturday, Sunday we don't have class. So this live class will be continued from Monday onwards. Okay, coming Monday. And the next thing is, whoever are preparing for TRB, kindly visit our website. There you can find the test series for TRB. It is almost free of cost only. You can just approach there. You will have to pay some least amount of money minimum, just for charging, just to avoid the tax and other things. Service charge like. So test series, here you can consider there are 230 tests. So we have framed the test in such a way that it will be covering all syllabus. Just for a revision, that's it. There is no big things. All are subject-wise, chapter-wise tests. This will be useful for you to cover the all topics and in a short manner, short span of time. That's it, sir. This is all for this lecture. Rest of things we will see in next class.